Yep. So you're more prone to errors that way. So today's lesson is commutative and associative laws, and these are laws that help us work with the numbers in a more easy fashion.
Oh, they all
Okay?
go to 100.
They all go to 100. So I asked the students, and this is for the sake of those of you who aren't here, the recording, I asked the students to do these two problems as a warm-up. And what we see is that if we're smart about numbers, and we use some laws we're going to talk about today, these two computations you can do quickly in your head versus just plowing through them step by step. So today's lesson will help you focus on using two laws, the commutative and associative laws, to make your life easier in math. We like easier lives in math. All right?
Yes, we do.
Yes, we do. So that's what we're going to focus on here. So you should have gotten 3,800 and 300. If you didn't use the laws and look for those smart shortcuts, you're more prone to mathematical errors and it takes you longer. Okay? So let's talk about how this relates to the properties, a lesson that appears at the end of chapter 2 in your textbook. All right. So the first thing we can use in mathematics to make our lives easier is the commutative law. In the Singapore textbook, they're called laws. In American textbook, they're called properties. That's why I had both names on the first slide. So what I want you to do right now is I want you to copy down this screen, commutative law, and the examples that I've given you. While you're copying them down, I want you to think about what that law is telling us we can do. And then we'll check in with you guys in a second. Okay, so you've copied down these examples. I've given you a numerical and an algebraic example in two different sets here. What would you say after looking at these examples the commutative law must say it's okay to do? What is it legal to do in mathematics? Mikey?
It's legal to switch the two factors or two numbers around in addition to multiplication.
Yeah, it's legal to move numbers if the problem is all addition or all multiplication. The commutative law says it's the moving property. All right, in my mind, I help myself remember that because commutative has M's in it, and it's the moving property. You can move numbers from the left side to the right side. The only thing that's changed is the position of the 5 and the 3, and it's the same thing. It doesn't change the value. Same thing down here in multiplication. Does the commutative property hold up for subtraction? Can we move the numbers in the subtraction problem and get the same thing? Can somebody give me a counter example? An example that shows you can't do that. Jack?
We do like 8 minus 3, 2 minus 5, 15 minus 15,
Right, so there is no law of commutative law of subtraction. Doesn't work. What about division? Here? No, same thing. 10 divided by 2 is 5, but 2 divided by 10 is 2/10 or a fifth, right? They're not equal. All right, so I say, remember it because it's got the M's in there for moving, or connect it to commuting. Many of your parents commute to work every morning and then commute back home, right? They move back and forth, but they don't change who they are, right? And that's what the commutative property is about. All right, so take a second and in your own words, in a way that you'll remember it, write out what the commutative law says we can do in mathematics, and then I'll ask a couple of you. Okay, in your own words, Caitlin.
You can switch the order, but you can't change the numbers.
You can switch the order, but you can't change the numbers. In what two kinds of problems? Subtraction. Addition, or what other kind? Whitest? Good. All right. What did you write in your notebook, Daryl?
The commutative law says that we can flip numbers in multiplication or division that will have the same product or something.
Good. You said multiplication or division, I think.
I mean, or
addition.
addition.
Yeah, good. All right, very good. Got that? It's the moving property. Let's move on. All right. Here are some examples about the associative law. So let's think about what the associative law means as we copy these into our notebook. All right, so you copied down these examples. What's going on with the associative law? What do these examples show you can do legally in mathematics? What's changing from the left side of this equation to the right side of the equation? Is the left side equal to the right side, first of all? Is the left side equal to the right side, Mary? Yes. What's changing on the left side and the right side? The only thing that's changing is where the parentheses are. Right? The numbers have not moved. 15, -8, 8, 15, -8, 8. The only thing that's changed is how they're grouped. Right? What's the difference between this first set of examples and the second set of examples? First set of examples and the second set. Logan?
It's addition and multiplication,
Right.
and they're different numbers.
They're different numbers also, but the main thing that I'm looking for is that the associative law applies to addition, once again, and multiplication. What doesn't it apply to? What doesn't it apply to? What do you think? You're not volunteering very much.
I don't
Not in the
volunteer.
volunteer crew. Come on. What operations no? Daryl?
Like whatever.
Says addition and multiplication, but what doesn't it? Couldn't you change the grouping on, do you think? Division and subtract. Okay. All right. So again, these are just if it's all addition or multiplication. You can change what's grouped, and it won't change the value, the sum or the product. You can see though that it can make your life a whole heck of a lot easier, especially in this example, right? 17 times 25 is much more difficult than doing 25 times 4. All right. So this is the grouping property. You might want to help yourself remember that because your associates are your buds that you hang out with. They're the people in your group, right? You can change groups if your life revolves only around addition or multiplication. All right. So this is the grouping property. Take a second in your own words to say what the associative law tells you you can do legally. So, associative law. Novacek, what did you put in your own words?
It lets you regroup things, addition and multiplication differently.
Good. It lets you regroup addition or multiplication without changing our products or sums. Good. All right. So let's put it to use because that's where it's really fun and interesting, right? Okay. You'll notice the directions here say, use the laws to make math easier. Yes, I love it when Mrs. Noble says, let's make it easier. Rearrange the problem and state the property you use, the property that allows you to make that change. Okay. So let's model that with example 1. We've got the problem of 37 times 25 times 4. What can we do in this problem to make this easy, y'all? Luke.
Switch 57 and switch 4 and move parentheses.
Move the parentheses. What do you want me to put the parentheses around?
25 and 4.
And why is that good, Luke?
Because that gives you 100 and then 37 and 100.
Easily to get 3,700. Now, what property did Luke use? What property did Luke use? Caitlin?
Associative law.
Associative. Very good. Of addition or multiplication, Caitlin?
Multiplication.
Good. Associative law of multiplication. So that's what you're gonna be doing this for a portion of your homework tonight. I tell kids, look for numbers that are compatible together, and that will help you figure out what kind of moves you should be making. So in example 2, we got 167 plus 389 plus 33. What could we do in this problem to get a nice calculation for us? What could we do with this one? Mary?
167 plus 33 equals 400.
So you're moving the 33 by the 167 because it equals 200. What's the answer to the whole problem then, Mary? 589. What property did Mary use when she moved the 33 and the 389? What property is that? Daryl? Yep, the commutative property or law. In this case, is it of addition or multiplication, Daryl? Good. And again, I can use property and law interchangeably. All right, I want you and your partner to do 3 and 4 together. Rearrange, simplify, and state what property you use to make it easier. So in example 3, what did your partnership do, Anna?
First we changed the parentheses to around 3.79 for 2.
Okay, so you change those parentheses like that. That's exactly what I would have done too in this problem. Why is that nice, Anna?
Because 79 plus 7 before the number.
Yep. So this problem becomes 4.8 plus what's the whole number? 6. So you get 10.8 is your simplified answer. What property did they use? They used one and only one property to do that, which was what? You guys in the back with me? What did they do? Melias? Yep, of addition or multiplication. Good. So they should have written their associative property or law of addition. Now, I think I was looking at Mary's, and she actually moved numbers and grouped them. So then it's okay, and you should state, I use both properties, associative and commutative property. All right. So if you switched places of the numbers at all, in addition to grouping them, you got to say both properties. And I want to talk about that with this one. So you can be with me, please. All right. In this example, some of you just automatically put all the negative numbers together. Sometimes that's a good strategy, sometimes it's not. How did you put the numbers together here? What did you do, Logan?
I did 29, negative 29
Yep.
plus negative 11 plus 53 minus negative, no, plus 3.
Yeah. And that's exactly the move I made. What did you do in your next line?
29 plus 11 is negative 40 plus 50.
Okay. Do you see that in this line, Logan changed how the numbers are? He moved them. So in this line, he used the commutative property. Then he went on further, even though he doesn't have parentheses there, what did he do? He did this, and he did this. So from this line to this line, he used the associative property. So he really should say, and all of you who did it similarly should say that you used both properties, commutative and associative. You moved and grouped. Even if you don't plop those parentheses in there, if you're doing them like they're in parentheses, you used it. Questions?
Nope.
All right, so now you can start your homework. I'll come around and check off your quizzes. Read the directions carefully. Don't be afraid to check with your neighbor. First